guys, Joe Pazinski here at Advanced Innovations. Welcome back to the shop. You know, I got an easy little project here for you on the board. Got to watch out when I say something's easy, right? But before we get to that, there's a couple things that I want to cover, and please hang in there for this. I'll make this as quick as possible. My friend and channel host of Outside Screwball, Mr. Chuck Bomarito, recently had one of his dearest friends have an injury in the shop, and it wasn't good. Mr. Chewy Rios was wearing gloves on a lathe, quick in and out, one of those, I'm just going to get over here real quick job. According to Chuck, I wasn't there. Chewy jumped into the machine just to knock something out real quick. Well, the machine grabbed the glove, grabbed his arm, pulled him in, and broke him up pretty good. Hopefully he's out of the hospital. It was a very bad injury, so I understand. If you don't know Chuck or you don't know Outside Screwball, the channel, go visit him. And he's got a message about this on his video list. Find that video, leave Chewy a heads up, you know, brighten up his day, let him know that you sympathize with his situation and wish him well. Anyway, Chuck is a fantastic guy. He's the kind of guy you'd want living next door to him, or living next door to you. So if you don't subscribe to Chuck, hit the subscribe button. Second, COVID virus. They're saying this social distancing thing is going to be good in the long run. Well, social distancing has got kind of a flip side to it, and one of the late night TV show hosts here in the US, I believe he's in the US, said don't practice social distancing, practice physical distancing, right? Stay 6 feet away from the guy in front of you, next to you, whatever, but pick up the phone. I mean, in this time of isolation, you're going to have to just know that you're getting stir crazy, cabin fever. I think even my dog has got cabin fever now. And that's funny to see a little 25-pound dog just wandering around lost because you can't go out. Anyway, so it is a physical distancing. It's the physical barrier that you want. But because everybody's feeling the pinch of this isolation, pick up the phone. Text messages are just not it. There's no emotion in electronic communication. So pick up the phone, say hello, how you doing? This really sucks, whatever. But human voices are good. And third, the alignment pins for the rotary table. Anybody that's been to my website sees the sold out on both of them. If you are interested, please know that they are in production and they will be back up and ready for sale very shortly. All right, that being said, let's take a look at this piece behind me. 303 stainless steel, 1.5" diameter material. You look at it, you say, okay, I need a 1/4 inch nose on it, inch long, 1.25 inch long, whatever it works out to. Coming down from 1.5" diameter material. At this point, you have to look at this and figure out what is the best way to approach this. If this was a very short projection, you don't want to take 99 small passes this way to get to that projection. You want to take one good pass this way, right? Makes sense. Why take 100 thou deep passes and take 9 of them when you can take 100 thou deep pass this way and go straight across to it? It's an easy part to do. Stock size, 1/4 inch fractional, inch long fractional, 50 thou radius, piece of cake. Well, it was a piece of cake until the engineer realized that he dropped the decimal point and things are about to get fun. Here's the problem. That is no longer a 50 thou radius. Mr. Decimal Point is going to make his ugly head known, and here we go. It is now a 500 radius. Oh, 500 radius. Now all you guys with the Shoreline machines, not that they're a bad machine, they're not, they're light, but you're not going to put a 1/2 inch radius form tool in a small hobby lathe and cut that radius. The machine's going to jump off the table and run out the door going, I didn't sign up for this. Well, you can do this. There is a technique. Now the first thing I look at when I see a part like this, and I know that you have large contact and you do not have a CNC machine, you have to start breaking this part into features. You have a cylindrical right here. You have the beginning of the radius, you have the end of the radius, and you have a vertical surface here. Okay, now we're looking at pieces. If you have the time, which I doubt that you will, you can break this up into steps, stagger it, and then just start picking off high spots and you're good to go. But the easiest way is to just take the size of the radius and leave that material on. Alright? That's the easiest way to do it. And then grab the form tool and start picking away at this square. Now you're going to say, well, it's not going to make any difference. I still have a full contact surface while I'm cutting that. Well, somewhat true, but not until the very last moment will you have all that contact. You can actually put that radius on there, nibbling away at it, and we're going to walk out to the machine. I'm going to show you how it's done because it's a good trick. It's a good technique. It's a good solid technique. What you don't want to do is wipe this completely out of your mind. Do not take that 1/2 inch radius form tool and cut that feature with that on a light machine, because all you're going to do is swear and curse, and you're going to have to take 5 thou deep passes, and when you get down here to the full contact area, it's still going to jump, chatter, bang, and burp, and you're going to go 50 thou would have been a lot easier. So take a walk out to the machine. I will try to show you clearly what I'm doing, and hopefully you're going to learn something. Let's take a walk. Alright, because I know you guys are going to ask, these are the stars of the show. This is a TPG 321 triangular insert I'm using right here with a KC 730 coating on it. Now, this is a Kennametal tool, and I know a lot of you guys have tried to find this particular tool, and that is an A, I believe, 123A. But pretty sure Kennametal has discontinued this tool. This is one of my favorites, but they still do the TPG 321, 322, 323 inserts. So if you're looking for one of these, Hertel, H-E-R-T-E-L, I believe is the substitute manufacturer. Notice the projection is kept to a minimum. And same thing with the high-speed 1/2 inch tool. Projection is kept to a minimum. Choke up on the tools as far as you can. That will really help to eliminate chatter. Now the setup itself. This machine is currently set for another job, so I'm not going to be messing with the block, but ideally you want everything over top of a support surface. Do not have this top of your compound extended. Alright, try to choke up everything, keep everything as compact as possible. Have minimal projection on your part. And this type of job is the type of job where a 6-jaw chuck would be absolutely fantastic, because the 120-degree separation in between the jaws on a 3-jaw chuck just lend itself to a weak spot ×3, and all that's going to do is invite chatter into the part. So let's be careful. I am going to run this job at 770 RPM with about a 7 thou per rev feed rate on this TPG. And I'll tell you, this thing will just peel this stainless off of here like it's butter. So let's reposition the camera and get this going. Alright, very first thing I'm going to do is establish a flat face. I will face this off, zero out my digital, and then I'm going to turn an 1¼ inch diameter. I'm going to probably leave it a little bit bigger than an 1¼ inch by an 1¼ inch long, and then I will back the tool out 520, 530-ish on the carriage, and then we're going to get it down to the 1/4 inch diameter, leaving a 1/2 inch step, symmetrical 1/2 inch step where the 1/4 inch meets the beginning of the radius. Then we'll switch over to the radius tool and change the camera angle, because I want you to see what's happening, and that's the whole idea behind this. So hang in there for a couple of seconds, let the chips fly, and we'll get it going. $100 thou deep passes, 770 RPM. Except for the facing cut. Everything else will be 100 thou deep. Okay, note to self, if you you have a piece of raw stock that has been cut and it's not really cut straight, don't worry about facing the entire face off clean if the diameter you're worried about is 1/4 inch in the center. If that 1/4 inch in the center cleans up, who cares what the saw cut marks are out here? It really doesn't matter, and it'll save you material in the long run. I'm going to back out 520 and reset my digital readout to 0. That is my new spot. Let's put a mark on there so you can see where the tool is. Right there. Whittle that down to 1/4 inch. Okay, now I think it is worth mentioning that the cut performance is going to change as the tool proceeds towards the center of the part. It's what they call a surface footage differential or surface footage change. It's not constant like you would find on a CNC lathe. On a CNC lathe, the RPM would increase as the tool got closer to the center to keep that surface footage constant. Now the best way to describe that is take a 50-foot rope and put your buddy on the end of it and send him 50 feet away, and as you spin, he's going to run a lot faster to keep up with you, right? You're going to be doing the same RPM as he is, but he's going to have to just go like a bat out of hell in order to keep up with your point in time wherever you are. Same thing's happening here. The larger diameter, the more material's coming around in the same period of time as the smaller diameter. So if you start having cutter performance as the diameter gets smaller, increase the RPM. Get it close. I'm going to do this by eye. I'm not going to measure. What's the point? Slowing the feed rate down. Here we go. Okay, now for this particular operation, you're going to see me do exactly what I told you not to do on the board, and there's a reason for that. This TPG insert, you can see the exposed face of that insert is facing along the turning direction and not the facing direction. So as a good rule of thumb, if you have an insert presented like this, the depth of cut when you make a facing cut, try to keep that facing cut within the radius on the nose of the tool. It will perform a lot better. If you were to try to take a 100 thou deep facing pass with an insert positioned like this, you'd have yourself a lot of trouble. Now the material that's left behind, this big chunk here, is for the radius. Now you can pick away at it with the radius tool, which is what I'm going to do, or you could put a chamfer tool in there and you could start knocking the edge off with the chamfer tool. Now you can do the same thing. Take a light pass, like a light turning pass with the chamfer, feed in, take another one until the angles meet, feed in until it, just lather, rinse, and repeat. But we are going to do this with a radius tool, and I think you're going to like what you see. It's pretty neat how this all happens. Alright, the initial contact with this tool is going to be about 45 degrees to the center of the radius, which means I'm going to go for the corner of the material and the tangent spot on the form tool. All right. Now when I do that, I take off the original corner, but in turn, I form two more corners. There and there. Now I'm going to attack those. All right. You take it in until the machine tells you not to. If it starts to chatter, if it's cutting good, fine. I go back for the center and pick away at it. Do the entire operation like this. There is no incorrect sequence right now. All that material has to come off. So whatever you can do, whatever you can get away with, attack it. And you can see that's exactly what I'm doing. I'm removing a considerable amount of material with very minimal effort. Done sequentially, just continue to attack the high spots, and you can see that the radius is starting to form. Now, ultimately, you are going to have to pay the piper here, and you're going to have some large contact. But keep an eye on your surface finish as well. If you start seeing little gray lines appear like those that are appearing here, you know you have a potential cold fusion situation, and that is when the material transfers to the tool and basically welds itself to the tool from lack of lubrication. Now we're going to put a little WD-40 on that. And when I use this WD-40, when I'm cutting with it and it's forming smoke, I am exhaling towards the smoke and blowing the smoke clear of the part so I can see what's going on. Once you have your numbers set for the diameter that you want to turn and the distance that you want to turn it, make sure those are your boundaries for the cut that you're making. And as the surface contact increases, reduce the RPM of the cut. Reduce the RPM of the machine. And you can see just a very mild chatter right there. If your machine has a coast feature where you can disengage the electronic brake or a jog button, and you do encounter some type of chatter on the part that you're cutting, you can jog the tool past the chatter, leave the tool in place, and just hit the jog button and cycle the machine incredibly slow. That'll take the high spots off of your chatter situation and help you to eliminate the bounce out of the tool. And once you know what your numbers are and where you're going, hit those final numbers ever so quickly. Momentarily keep your hand on the on the cross slide and the hand wheel, and in a coordinated effort, hit your numbers and get out. Do not sit there. If you sit there, it's going to scream and the cut's going to go deeper and you're just going to have a mess. We're going to have to do some hand work on this because I want to mirror finish when I'm done, just because that's what I'm looking for. And if you don't take the form tool out of the machine and address the cold fusion that gives you those tear lines, well, they're going to be there right until the end, and you're not going to get them out without heavy emery or file. And you can see that little intermittent blip in the film right there. That was the jogging going on in order to take off the chatter. This would be a much more successful operation in a 6-jaw chuck or board soft jaws. Let's throw a little chamfer on there and start with the emery. Okay, the tear lines that you see in the material, this is good. When you have a really nice finish and you start getting these gray lines in it, take a look at the tool that you're using, because there's a very good possibility that the tool is damaged or you have a cold weld situation. Okay, now you can see by the edge of this tool there is some cold welded material on there. Right dead center, right on the very tip back here. See it? You can feel it too. Take a file and knock that off. You can take a stone and stone it down. But sometimes once it gets on there from a dry operation, because I didn't feel like sucking smoke for this whole demonstration, but for a dry operation like that, you can expect that to happen. And if you try to knock that off on a piece of carbide, you may take the edge of the carbide with you. So be careful when you remove it. Now, old timers, forgive the terminology here, guys, but old timers used to call that fly shit. And once that gets on a part, it is really hard to get off. what I will do now to this part, and you can see the result of that cold fusion, tears those little gray lines in it. I'm going to hit this with a round file, and as I file this, I am going to be spinning the file so that the track of the file does not clog up. It probably will still encounter some debris, but if you do not spin it, you're going to have a problem. Alright, so let me shine it up, and I'll get back. Alright, to finish this feature out, I'm going to use a round file. And it's really important to take a good hard look at how I'm going to do this. I am leaning on the headstock of the machine. I'm going to protect the tip and the handle of the file. And pay attention to how I'm rolling this file to keep this file from loading up. If you use a file like this and you just go right at it, naturally you can sweep the radius of the part with it, but chances are it's going to load up pretty quick. Now, if you were to take a screw and turn a screw clockwise into a right-hand thread hole and drive it in really quick, it's going to slip right in because the helix of the screw matches the hole. Easy, right? If you were to turn that screw in reverse and drive it into that hole, well, you're going to meet with a whole lot of resistance. And that's the same exact thing that happens with the helix of a round file. You can almost neutralize the cutting action of the file by twisting the handle of the file as you traverse the part. You want it to cut more, you go to the opposite way. You want it to cut less, you go with it. And believe me, you'll feel it. Take a round file sometime and try it. You will feel the resistance almost like it sticks because it's cutting, and that's your resistance. Throughout this particular demonstration, I went both ways on that file, and you can see it if you're looking for it. It's something I do naturally, and if you want a deeper cut, go against the helix of the file. If you want a lighter cut, go with it, but just go nice and slow. The speed with which you push it across the part also changes the cutting performance. Jack up the RPM a little bit, start moving in with the emery. As soon as you hit the emery to the part, you're going to see anything you may have missed with the file. I think the radius looks pretty good on this one, but we still have a little bit of a witness mark. And with further investigation, I found that OD witness mark, the one that's on the face towards the outer edge, that is from a top relief on the radius tool that was not intended to cut beyond the profile of the radius. So that got me, and I will clean that up. So if you see it go away with no particular explanation, well, it made me crazy, and I just couldn't deal with it because I have to look at this part for a while. I'm also going to take the TPG tool, and I am going to finish off the nose of this tool so it blends real nice. And one thing about those TPGs, if you go in reverse with that tool, the back side of a TPG insert is always sharp because you're always cutting with the face of it. So it's like almost like having a roughing and a finishing tool all in one. Step down with the emeries. Do not wrap anything around your finger as you're doing this. Paper is better because paper tears if it grabs. And adjust the pressure to get a better finish. You'll be happy with the results. Off camera, I tweaked the radius tool a little bit, came back and took a facing pass, and finished off the nose with the back side of the TPG insert, which is really nice because it's always sharp. Going to attack this with some emery. We're going to work down from a heavier grade into a smaller grade. That's about a 150. You can see we still have some tear lines in it, but if you work on those and don't keep the emery sitting still, you should be able to work them out pretty easily. They're only a thou thick, but I tell you, on a large surface like this, 1/1000th of an inch is forever trying to get that out of there. But rest assured, I will get that out of there. This is accelerated footage because if you want a nice finish, you got to take your time on it. That is a cloth, and 2-inch emery cloth that I'm using there, and I don't prefer cloth on a lathe. I like paper on a lathe because if it grabs, the paper just detonates and it doesn't hurt you. We're going to work our way through the emeries. If you like what you see, make sure you get all the dust off from the emery operation before you put any kind of a polish on.
And once you put the polish on, it is payday. So this should be a pretty nice looking part when we're done here. This is Blue Magic Polish. I've been using this for a couple of weeks now, and I'm really liking it. You can see how it brings the shine of that stainless out like it was chrome plated. Love it.
Okay, now that is a considerable radius. I don't care which machine you have. If you're doing that manually, stepping it in like I showed you, chase the points around. It doesn't matter if it's 1 point, 2, 3, however many you make. Chase them around and keep cutting them off. Try to keep as minimal contact from the tool in contact with the part as you can until the very last geometry needs to form. This was finished off with a light hit on a fine round file. There are still some superficial lines in that. You can see them right around this area right here. They would come out relatively easy, but it's just redundant video time. Hit it with a 180 emery, went to a 400 emery, and then went to a Blue Magic metal polish for that. Done with a paper towel, because a paper towel tears and pulls out of your hand a lot easier. If you use a rag, chances are the rag is going to offer up a little bit more resistance if the jaws catch it. So use a paper towel or a piece of tissue paper, napkin, Kleenex, whatever you got. That's how you do it, guys. Step it around, leave the material on there as you see fit, jump it point to point to point to point, finish the radius. It is possible. Alright, hope you liked it. Thanks for watching.